Hello, welcome to Istio Weekly. Thank you all for joining today. We'll be talking about how to integrate external certificate authorities with Istio, and we have a special guest, Josh Van Loan, Senior Software Engineer at JetStack and contributor to the Cert Manager project, which was first created by JetStack, and it's now part of the CNCF Sandbox. CNCF acknowledges Cert Manager as the de facto solution for managing X.509 certificates in Kubernetes. So Josh will show us how to configure Istio to use an external certificate authority to distribute certificates to your workloads. And as always, we'll have a dedicated time for Q&A after the presentation. So if you have any questions or comments, please put them in the chat. We'll do our best to get them answered. But before diving into today's topic, let's take a moment, as always, to cover some recent highlights in the mesh world. As always, see the show notes in the description for details and links. So Istio as an API gateway, Jimmy Song's latest blog post discusses how the functionality of an API gateway and service mesh are converging in certain ways. Jimmy provides an overview of how to use Istio gateways to expose services and also a comparison between using traditional API gateways and integrating API gateway features into the mesh, sort of pros and cons of each. So check that out if you're interested in API gateway functionality inside the mesh. Peter?
I wrote a blog post called Get Started in Envoy in 5 minutes. I don't know if it'll probably take you more, but let's say it's going to take you 5 minutes. So this is for anyone who's looking to dive into Envoy. I'm covering the basics of what Envoy can do. And I also explain and use the open source command line tool called Funky that makes setting up Envoy easy. So go check it out at Tetra.io 5-minute Envoy.
And we also thought you'd like to look at Jimmy Song's article about how to debug microservices in Kubernetes. He provides an introduction to the common tools and processes, and also how Istio impacts the debugging process.
And the last but not least, so if any of you have taken my Istio Fundamentals course, I think we mentioned it in the last episode. We also want to mention that Tetrate offers an Istio certification program on Tetrate Academy. So once you've mastered all the Istio fundamentals, you can then go through the certification program and then show off your Istio expertise. You can get a badge and a certificate. And if you want to do that, go to academy.tetrate.io and check that out as well.
And finally, we want to hear from you. What else is happening in the service mesh world? What topics would you like us to cover here? Please leave your thoughts in the comments to the video and at GitHub. Again, link in the description. And with that, we'll turn the mic over to Josh.
All right, Josh, it's all you.
Cool. Thanks, guys. Thanks for having me. Yes. So hi. I'm Josh. I'm going to do a talk on external CAs with Istio. Again, I'm Josh. I'm work for JetStack, so we're a Venafi company. I'm on the Cert Manager team. So what I want to cover today for this talk, first of all, is service identity. So chat a bit about service identity in Istio and how that's set up. Trust distribution, so how entities or identities inside the Istio mesh trust each other, and how trust is distributed. We're going to talk a bit about the default installation of Istio and how that's set up with with the kind of basic like service identity with the kind of self-signed CAs. A bit about external CAs, the benefits of using external CA, why you might want to use one, how you can use an external CA by plugging it in, and then talk about Kubernetes CSR, so using the kind of Kubernetes CSR resource as a strategy for using an external CA. And then finally, we're going to talk about Istio CSR, which is a project I worked on, and that integrates more tightly with Cert Manager for bringing in an external CA to Istio. Cool. So yeah, without further ado, service identity. So this first diagram is kind of like a high level, kind of stripped down, kind of look at what Istio looks like and its different components. Kind of briefly go through it. I'm sure a lot of people here already have like a fairly good idea of what this looks like. The kind of main things of concern is we have this control plane down here. So that's made up of Istio-D. Previously, it was off different components, but now that's bundled into the same process. This is a control plane. This is responsible for distributing certificates, pushing config into the sidecar proxies, etc. This is kind of what your administrator or your kind of mesh administrator is kind of interacting with. Then you have the data plane. So this is where your workloads live, right? And your workloads are sidecarred with a proxy, and it's the proxies with what interfaces with the mesh. So it's the proxy doing the mutual TLS traffic between each kind of other identities in the mesh, and your services, your the developers that kind of write their application and deploy to, they interface directly with their corresponding proxy. So it's the proxy that's taking or intercepting all the traffic and passing it on to the other proxies. This is kind of a bird's eye view. And of course, in order for all of this to happen, things need to talk to each other. And with Istio, everything needs to talk to each other securely, right? A malicious actor, if we're inside the mesh, you don't want a malicious actor to push random config or whatever. So in order to do that, it implements normal TLS or mutual TLS. And the way that happens is through normal X509 certificates. So these are the same kind of protocol or concept that you use for kind of public internet, let's say. And an X509 certificate, is just a document which has been signed by some trusted authority containing some identity about you. In the kind of classical sense, if we talk about the public internet, we normally are kind of dealing with DNS as the identity. So if you think about me as a client, I want to talk to google.com. I need to verify that when I connect to a service who say they're google.com, that they really are google.com, right? So the way that happens is google.com present me with their certificate and some signed data, and I can verify that who I'm talking to really is google.com. Well, in the Istio world, or in the mesh world, that's a bit different, right? DNS doesn't necessarily, or even ever, or a service might be assigned multiple DNS names. So DNS is a great abstraction in the kind of service mesh world. So it needs a different abstraction, and Istio therefore uses something called SPIFFE. So SPIFFE is a framework that stands for Secure Production Identity Framework for Everyone, of a tongue twister. And SPIFFE is a framework, as I said. It's a set of protocols, APIs, and kind of design philosophies for creating a kind of a zero trust network with identities that can communicate with each other, or entities that can communicate with each other, and they can verify each other's identities. So if you take this to the kind of the Istio world, what this means is that we will have these X509 certificates, and instead of the DNS names that I mentioned before, instead they will be encoded with URI names in this SPIFFE format. The SPIFFE format, really, all it is it's encoding the identity of whatever entity it is. And in the Kubernetes world, rather than DNS, a better abstraction is service account. Each pod, for example, in Kubernetes will be backed by some sort of service account, and so that's a better abstraction. SPIFFE format is the URI inside these certificates. It's pretty easy. So all it is the trust domain. So this is typically trust domains are typically split by mesh clusters. So you might have Europe-2, mycompany.org or Europe-3, etc., etc. And then after that trust domain, it then follows the kind of workload identifier. Again, in Kubernetes, service accounts is a good abstraction. This basically encodes a service account. So service account's a namespace. So you have the namespace followed by namespace the service account lives in, service account, and then the name of the service account. It's quite key to understand that that is how identity is represented in Istio. As I'm sure you know, that's how you can make authorization decisions, policy decisions, networking decisions based on these kind of fundamental parts of using this identity. Identity does form the foundation that you can build kind of higher level features on, more useful features. Cool. So that was a quick run through of service identity in Istio. So covered Istio uses X509 certificates to encode identity and enable mutual TLS, and that uses SPIFFE. Cool. Next, we're going to talk about trust distribution. So again, talk about the public internet, and I'm on my laptop and I want to connect to Google.com, right? And I need to verify I'm actually talking to Google.com. Well, in the public internet kind of scenario, what happens is, I'm on a laptop, it's pre-installed with some kind of operating system, right? And with that operating system will come a bunch of CA bundles that are installed. And so when Google present their certificate to me, I can then cross-reference that with some pre-installed CA bundles and ensure that at least one of those CA bundles, or exactly one of those CA bundles, assigned that Google.com certificate. Well, in our private PKI world, that's not the same, and it's not advisable and will become extremely expensive incredibly quickly to attempt to try and sign for your private PKI certificate. So instead, we need to be distributing trust ourselves, right? So it's typical, for example, if you're working in a large organization or what have you, you might need to install some CA bundles into your web browser or whatever to connect to your company's internal systems on their network. And it's the same with Istio, right? So the way that Istio does this is through a couple ways, but the primary way is for distributing a config map to a well-known location in every single namespace. So then result being is that IstioD will start, it will have some kind of base CA data that it knows it needs to populate around, and it's going to write that to a config map in every namespace. And the end result being is that, again, the example here of our kind of Istio workload running in the cluster, once the pod starts, it's able to mount that config map as a normal config map in Kubernetes. And that means when our Istio workload, the Istio agent, makes its initial connection to Istio-D, and Istio-D presents its own Istio-D certificate, Istio agent is then ready to kind of accept that connection and formulate that kind of like initial TLS connection. And again, it will then, for the whole time after that, continue to use those CA bundles to connect to other workloads in a cluster, etc. Here's just a kind of small look. Again, it's just a well-known config map in every namespace. The second way of distributing trust is through the mesh config. So the mesh config has some first-class support for adding custom CA data that can be pushed to Istio workloads through XDS. This is what it looks like. This CA bundle is not appropriate for the workload to connect to Istio-D. The reason for that is that this will only be pushed, obviously, after a workload has joined the mesh, which means that it does at some point it does initially need some kind of CA data already preloaded in. So the config map kind of trust distribution is still required here. But this is good for potentially, the workload connecting to other services outside the mesh, that kind of thing. So you can either inline kind of encode your PEM certificate here. And there's also support for a SPIFFE bundle URL. So again, this is one of the SPIFFE SPIFFE APIs that have been written up. So it's SPIFFE compatible. So for example, if you have a Spire server or another SPIFFE compatible server that is distributing trust bundles, Istio-D can discover it that way. Cool. So yeah, it's just another bird's eye view to see the two different methods that you can use. So to wrap it up, trust bundles are propagated by the control plane, so IstioD, and you can use config maps by the control plane or the mesh config. Cool. So next is the default installation. So we've covered service identity, how trust distribution works. Now let's actually talk about certificates in Istio. Again, a quick look at the kind of bird's eye view. It's this Citadel, which is a process in Istio-D, and previously a separate process. And in the default installation, that is what's going to be responsible for signing our certificates and distributing our roots of trust. Again, in the default installation, when Istio-D starts, if we don't give it any, if we just give it no config whatsoever, it's going to self-sign itself a CA, and it's going to be using that for signing each of the Istio workloads. And we'll chat a bit about how we can improve that in a bit. But a quick demo just to show that happening. So in theory, I have a GKE cluster running here. Cool. And I'm just going to literally just install Istio-CTL, like Istio-CTL install, the base install, and then I'm going to just show that the config map has been propagated with the CA data. So let's install Istio. Hopefully not take too long. Cool. So the only reason why I wanted to show this, as I'm sure we've all probably tried this before, just Istio-CTL install, is that I wanted to show just a couple of log lines effectively. What I wanted to show was that Istio-D in the log lines, you can see it's using a self-signed certificate as a CA certificate. And yeah, that's it pretty much. And it's outputting its CA. And you can see here that the kind of config map has been generated. But yeah, again, this is kind of self-signed, and Istio-D is signing the certificates kind of in memory for the one it generated. But to recap, the certificate is self-signed in the default case, and it's signed and managed through Citadel. Now to talk about external CAs. So external CAs, why would you want to use them? What's the benefit? There are 5 reasons, as I see them, for using external CAs. So I think first and foremost, at least for me, is protecting the CA private keys. You have your CA private key or the intermediate or what have you, you have the keys to the castle, right? If you have access to that private key, you can sign whatever certificate you want, and a malicious actor, a bad actor can effectively do whatever they want. They can put themselves into the network and pretend to be whoever they want. So first and foremost, protect the private keys. Yeah, so this prevents against a bad actor looking at yeah. Number 2 is observability. So having an external CA that might be backed by some kind of managed service or something like this, it means that security teams are able to see what certificates are being signed, what are the shape of those certificates, what private keys are being used, who, what, where, how, sort of thing. Number 3 is policy. Again, that's restricting what certificates can be signed, what identities can be signed for, key sizes, that sort of thing. Number 4, integration with existing PKI infrastructure. So typically large organizations already have a PKI set up. Perhaps a company's moving to the cloud, or they're already in the cloud and they have PKI already set up. So that's a big motivator for wanting to use an external CA. And number 5, shared roots of trust. So if you have multi-meshes across different clusters, across different clouds, having shared roots of trust means that I have an intermediate per mesh, let's say, as the NIST recommendation, then it's far easier for those clusters to connect to each other. They're all kind of speaking the same language, let's say. So as the first example for using external CA, we're going to use the sort of base strategy, which is the plugging it in. This is much the same as the default install. All I'm doing is I'm effectively pre-warming SDOD's secrets that it's using anyway. So I'll show you in a second. When SDOD starts, it's going to look for that secret location. If it doesn't see anything there, then it's going to self-sign its one. But if something is already there, then it's going to use that one. So let's open up the demo. 101. Cool. So as you can see here, I have a few files in here. These are basically some CA certificates that I've got preloaded with private key and such. And all I'm going to do is create them, or create the secret first, rather, that SDOD is going to look at, and then I'm going to install SDO. So let's try and do that quickly. Yep. Cool. Cool. Hopefully, if we check the SDOD logs, you'll see here already that I have 2 CA bundles installed. Keen eye will notice that one of them is the CA certificate that I showed before. And you can see here that SDOD is using a local CA certificate. Again, not too exciting, nothing too crazy. I'm sure people are maybe familiar with that example. But again, we can do better. So why would you want to use an external CA? Better security, shared roots of trust. I demonstrated the plugin behavior, which is much the same as similar to the default. The issue with this strategy again is that the private key is living in a secret in Kubernetes. If your etcd was dumped, or your secret was accidentally published to GitHub, or what have you, we can do better than this, basically. So the next strategy I'm going to walk through is Kubernetes CSR. So Kubernetes CSR is a Kubernetes core resource, so it's a certificate sign request. And this is effectively a one-shot resource inside Kubernetes itself. So it's designed for, obviously, signing certificate requests. 3 main kind of points of interest, I think, for this resource is number 1, it encodes a requester. So this encodes the identity, which is creating the resource, which will come important in a second. Next is the signer. So this references the kind of CA that we want to actually sign this certificate sign request. And number 3, the approver. So each one of these are kind of the 3 different identities which kind of make up the life cycle of the certificate sign request, basically. So the way this works in practice, in Kubernetes in general, is I have service A, an approver, and a signer. Service A will create a certificate sign request resource. An approver will decide whether it wants to approve or deny that resource. An approver can do that on however it sees fit. It can try and match the requester's identity to the identity which is encoded in the CSR kind of document. It can check the private key size, all those kinds of things. So assuming that it approved it and didn't deny it, it's then the signer will then sign the resource, and then once that's been populated with a signed certificate, the server side can then obviously read it back and do what it wants with it. Taking it back to Site Manager, so Site Manager released with a 1.5 beta yesterday, following up with our kind of full release in a few days. We're testing out the kind of new Kubernetes 122, which looks good so far. So yeah, it looks good for the 1.5 release. We're using the beta today. The beta ships with a new issuer, or some new issuers, or at least support for signing these certificate signing requests using the kind of core issuers that we have today. So an issuer in Cert Manager is effectively like a representation of a CA. You can kind of think of it as a configuration of a client to access a CA. So in the example I'm going to show in a minute. Oh, it's gone back too far. If I'm going to use the Vault issuer, so this is the configuration of what my Vault issuer is going to look like, and the end result being is I'm going to configure my Istio mesh to use this certificate signing request resource, and I'm going to point it to my Vault issuer. The Cert Manager is going to sign those certificate signing requests against Vault. So it's not going to be my Vault instance, which is going to be ending up signing my PKI for Istio. So the way that flow works is I have a workload that starts up, service A. Just like normal, it's going to request its certificate against Istio-D using the kind of typical gRPC strategy that Istio uses. Istio-D is then going to create that certificate signing request. It's also going to approve that request since it created it itself. Cert Manager is going to go ahead and do the signing, and then that obviously gets passed back to Istio-D, and then back to the Istio workload. Cool. So let's do a bit of demo of that in action. Let's make sure I'm in the correct queue context. Let's go to that one. So once again, just a GKE cluster running here. So I've got Cert Manager installed, of course, and I've also got my Vault instance installed. So my Vault instance is running inside the cluster, but of course your Vault instance, it could run wherever you'd like it to be, as long as Cert Manager's got some kind of connectivity to it. Just for completeness, I'll also show that I've got my Vault issuer installed, and again, this is just kind of a more long-winded kind of typical qttl output of a resource, but yeah, it's the same one that I showed on the slide before. So the next thing to do is to install Istio. So what I'm going to do is apply it with this config. So there's a couple of things of note inside this config. First of all, we need to give Istio-D those credentials, or those permissions rather, those RBAC permissions in Kubernetes to, first of all, create that signer request resource, approve it, as well as reference a Cert Manager issuer. So this is more of a Cert Manager specific here. So it's an extra check that we do. I'm then further down going to reference the Cert Manager issuer I just showed you there. And I'm also going to mount in the CA certificate of Vault. So I've got a secret which I've preloaded into the Istio system namespace. So that's so that Istio-D can see the kind of root certificate. Cool. So let's do it. As that's going along, let's see if we can catch. Oh, not that one. I want that. So you might have just seen there that flash on the screen. So that was the certificate sign request resource. And what happened there is Istio-D created the resource, approved it, cert manager signed it, IstioD read the certificate from it, and then deleted the resource. But it all happens a bit quick. But yeah, you can kind of see a glance of it running by. So that's all set up. Everything looks green. A kind of demonstration. I'm just going to apply some dummy applications here. So if anyone's gone through Istio docs, they're probably familiar with the sleep and HTTBin dummy apps to install to kind of test out connectivity and that kind of thing. So that's what I'm installing here, along with strict mutual TLS. No. That looks good. Next, I'm just going to output, I think it's, yes, HTTBin's serving certificate here. So it's just a kind of a long OpenSSL kind of client connect from the Sleep container over to the HTTPin container. The reason why I want to do that is that you can see here the root certmanager.io. You can see that it's forming the right chain basically and coming from the correct root, and that is matching root cert here. You can see that they have the same name. Cool, and again, none of the private key material is no longer living in secrets. This is all happening inside Vault, so Vault's doing all the signing. The private key is obviously protected by Vault. It's only the CA data that's being propagated in resources, and each workflow's private key is obviously stored in memory. So that's all nice. Cool, so let's go back to the slides. Cool, so Kubernetes CSR. We can leverage Kubernetes core resources for signing our Istio mesh, and IstioD acts as the RA, so the registration authority, the thing doing the kind of verification, verifying the Istio workloads and sending off their request for signing. Cool. Then finally, final demo is Istio CSR. So I worked on Istio CSR. And Istio CSR is similar to the Kubernetes CSR strategy, except it's sort of more tightly coupled with Cert Manager itself. So Istio CSR is another service that runs in your cluster, and it acts as the RA certificate. So in this case, when the workloads start in the kind of Istio mesh, they no longer interface with IstioD, they now interface with Istio CSR. So it's Istio CSR that takes care of the kind of verification and creating of request resources. Takes care of the trust distribution, and yes, Cert Manager acts as the CA. What's nice about Istio CSR is instead of being confined to what issuers support the Kubernetes core specific sign and request resource, this instead is supported by any issuer resource that are currently available in Cert Manager. So we have the core resources in Cert Manager, so the Acme issuer and Vault and such, but there's loads of external issuers now supported with Cert Manager. So any one of those which can effectively sign a certificate with a URI sans can work for this. This is just kind of a quick walkthrough of Cert Manager's certificate request resource. The point is to show it behaves much similar. We have our requester fields, which are set, which are populated by the identity who created the certificate request. So in this case, it's Istio CSR. We have an issuer, which is analogous to the signer name. So this is the kind of CA that you wish to sign the thing. And again, the approver. So we still have the kind of approval API. The flow is a bit different, but it looks much the same as the CSR one. You can just see there's a one more entity involved. So let's say my Istio workload starts up. It's configured to request a certificate from Istio CSR. Istio CSR accepts the request. It verifies the contents of their request. It matches against the pod service account. It verifies the key, and once it's happy, it's going to go ahead and create that certificate request resource. And the demonstration that I have set up, I've also got Policy Approver set up. So this is another Cert Manager project, which it automates that kind of approval mechanism that we have from that Cert Manager certificate request. The benefit here is that we have extra checks, right? So although Istio CSR is okay to everything, you could in theory encode Policy Approver to do some further checks to kind of limit what identities can be requested, and there's no identities or no random certificates that can be requested in the cluster, and that's configured all through CRDs. And I'll show an example of what we have set up in the demo in a second. Lastly, once the Policy Approver is assuming approved the request, lastly, we'll have a Google CAS issuer sign the request. So I have Google CAS issuer installed. I've set up a kind of a certificate authority in Google CAS. So Google CAS is Google's kind of CA provider product. So I believe all the CAs are backed by HSMs, and it's all securely signed, kind of in the Google Magic kind of network. So yeah, I've got a Google CAS issuer installed. Of course, once it signs it, it goes back and heads back. Yeah, so it completes kind of the flow and the life cycle. So in this setup, before in the previous example, I had Vault, which was signing, managing signing the PKI and have the root of trust. In this case, in this example, I've got my Google CAS. Cool. Demo time. So let's go back to the terminal. Go to demo Istio CSR. Change my queue context again. Cool. Cool. So if I just list pods. So you can see here again, I've got Cert Manager installed. I've got my Istio CSR installed, the Google CAS issuer, and the Policy Approver. I've also got the JetStat Secure agent, which I'll show in a second, and that's all we need. The policy that I mentioned before. So Policy Approver acts much the same as you expect things like network policy to behave. Not an Istio expert, I'm sure there's an Agilus in Istio as well. So yes, in Policy Approver basically accepts these kind of policy profiles is what I like to kind of think of them as. Yeah, and that gates basically what could be signed by who, and that's kind of federated around using RBAC in Kubernetes. So that's there. Next thing is to show you the Istio config, of course. So yeah, similar to the CSR again. In this case, changing the trust domain. Just because. The CA address. So this particular piece of config will instruct all Istio workloads to request their certificates from Istio CSR. So that's quite important because that basically ensures that instead of trying to connect to Istio-D and obviously never getting a reply or getting rejected, it instead instructs them to request it from the Istio CSR service. Enable CA server false, so that instructs Istio-D not to do any kind of self-signing or any of that business. And the final thing to mount in Istio-D's serving certificate, which is loaded in. Cool. So with any luck, hit install and click yes, and that will do its thing. If you go to another terminal and do something like this. So what I'm doing here is listing all the certificate requests in the cluster. With any luck, there we are. You can see some new ones coming in. Typically, these would like the CSR be deleted, instantly. But I thought just for brevity, I'd preserve them switch the flag to preserve them. You can see here that they're being created, they're being approved. There's some denied there when I was playing around with it, with the kind of policy. Yeah, and we can see them all there. Cool. That looks like it's all installed. Again, I'll go ahead and apply the kind of demo applications. It's up and running. Cool. I'll do the test again. And if we take a look, the issuer in this case was SiteManager.io is the CSR Josh for now. And that basically maps to what I have configured in Google Cast, basically, to show that it's all coming from, yeah, I believe this is the one here that it's coming from. Yeah. Yeah, the JetStack Secure agent as well. This means that it's also connecting to our product. So again, this is a nice observability piece that I was mentioning before about some of the benefits of using external CAs. I can basically see from this view, perhaps I'm in the security team or something like that, what's being signed from where, is it being used, that sort of thing. Great. If I go back to the slides. Cool. So SCSR leverages SiteManager for signing, and we can use existing SiteManager issuers in tooling. So yeah, the JetStack Secure page that I was mentioning about, different issuers, Google Cast, etc. Cool. So to wrap it up, I'm going to go through what we covered. So Istio uses specific documents for identity. So it uses X509 certificates, and they get encoded with those SPIFFE identities. Istio has different methods for trust attribution. So you have that kind of config map method, or that mesh config kind of inline method. Default installation uses the self-signed, which obviously isn't great. We covered why external CAs are good, security, shared routes, that sort of thing. External CAs can be plugged in. Again, they have a lot of the same shortcomings that the default installation has. You can use Kubernetes CSR, or alternatively use something like Istio CSR, and you get all the trimmings, let's say, that come with that. Cool. Onwards and upwards. I just wanted to briefly touch on, there's some work going on upstream in this area. So there's the Istio Workload Certificate API. There's a design document there. I think we'll publish these slides so you can have a look at that. Basically, there's kind of some ideas on how to unify some of these solutions, how to make them perhaps more first-class citizens in the config, and yeah, some other experimentations going on. I experimented with the CSI drive, for example. So that would be like a kind of gRPC we kind of looked at before, that all of these kind of rely on, perhaps doing like a file mount kind of strategy, which is, yeah, but again, that's all kind of experimentation and kind of future stuff. Cool, that's it for me. Yeah, I don't know if anyone has any questions. I've lost the chat myself.
Awesome, Josh. This was, I think the demo and the presentation was on point. There are some questions. I'll just read them through. So Logan is asking, what type of architecture is usually present for managing certificates with multiple clusters? Do you centralize the cert manager, or do you have to install one per cluster?
Yeah, so cert manager is a one per cluster. Same with any kind of Kubernetes operator. But that's not to say the thing that's actually backing your CA, you need one per cluster. In fact, you might not want to, or, talking about this kind of shared roots of trust. But indeed, you'd want one cert manager per cluster. You need one cert manager per cluster. And then likely one intermediate per cluster. But these are all kind of backed by the same kind of root CA. So I might have my Google Cast, a single root CA, 5,000-6,000 intermediates, and each one of those cert managers in each cluster will then be connecting to the individual intermediate. Yes, if that answers the question, hopefully.
Okay, yeah. Also, Vivek is asking is if the JetStack UI for CSR, if that's available as an open source product. I'm assuming that's the UI that you showed where you had all the certificates listed, or all the requests, I guess, listed.
Hmm. Yes, as far as I understand, you can kind of get started and have I think it's like a free trial, I believe, or kind of a first cluster type free trial. But yeah, it's certainly up for trying it out. I'm sure if you email nicely, if you can't, I'm sure we'll be able to give you access. Yeah.
Yeah, there's also a follow-up, I guess, from Logan on the
Hmm.
multi-cluster. So if you're managing your certs externally, could you then potentially create trusts, let's say, between Linkerd and Istio, assuming both of them are configured properly, or
Yes.
does Spiffy ID cause any issues here or anything like that?
Nope, that definitely should work, and it should be the same as two HTTP clients just talking to each other. So long as they both understand, I think this is true, they both understand secure identities, or at least their policy or authorization policy is expressive enough to make decisions arbitrarily about identity, then it's certainly possible, and they'll just treat each other like other TLS clients or servers. Yeah.
Yeah. There's another one from Vivek. He's asking alerts for the failed CSRs. Are those configured via metrics only? I'm not sure if this.
Alerts for CSR.
Maybe
As
if you can like configure alerts for your failed CSR somehow,
Alerts.
or well, we'll wait if Vivek can clarify the question. Yeah, I think it was an awesome demo. One thing that like I wanted to ask is, like, in all your demos, like in the last one, you had everything installed already. How is like what's the experience of actually setting this up? Because right now you have everything set up already. Is it like a Helm chart, or a bunch of YAMLs that you have to throw around? And
Sure. Yeah. I think for these demos, so I don't operate, or I don't administer. I'm not an administrator for a fleet of clusters, let's say. So I'm kind of primarily a developer. So I don't necessarily, I kind of throw things around, let's say, and kind of have bits of manifest everywhere. But in this particular case, I think a mix of Helm, Helm for the install of Cert Manager, Istio CSR. I had some YAML in different places for Vault, that kind of thing. So yeah, more cavalier than likely you should be for production. So, yeah.
oh yeah, okay. So Vivek clarified the question. So sometimes issuers can be faulty and signing is not successful. So I'm assuming what happens like is that I'm assuming that's like
Okay.
surfaced somewhere somehow, or how is that like?
Yeah. So I'm not sure if I have any examples, or I don't have any examples to show here. But yeah, for example, JSAT Secure would be able to alert on failed certificate requests. Cert Manager exposes metrics. So yeah, it's simple enough to add some, if it's on client, Prometheus, and then alert manager metrics for those kinds of things. Yeah.
Awesome. Orion, do you have any questions?
No, Josh, that was awesome. Thanks so much for putting this together. We hope everyone found it useful. And we hope that you'll join us in 2 weeks for the next episode of Istio Weekly. And Josh has some, contact info and other stuff that we'll also put in the show notes. And we've also put tutorial material up at GitHub, github.io/tetratelabs.io/Istio Weekly. You can chat with us on the Get Istio channel in the Istio Slack workspace, slack.istio.io, or leave a comment on this video, and you can reach Jetstack at jetstack.io, or is it jetstack.com? I should have written that down. IO. Excellent. Thank you. All right. Well, thanks again, Josh. That was really cool. It's great to get to know you, and hopefully we'll see you soon. See you all in 2 weeks, where we have episode 9 coming up.
Yeah, and one thing I want to add, in case like any of you watching, listening, If you have any like ideas for the next episodes, if you have anything interesting that you are working on or with in the like Istio Service Mesh Kubernetes area, feel free to like ping us. That's how we got Josh onto this episode, and I think it was very useful, and it was an awesome demo.
Agreed.
All right, thank you very much, and we'll see you in 2 weeks.